Hi, everybody. Good morning. Thank you guys for making it out to the last day of JNUC. I hope everyone had a wonderful time at the party. And again, very glad you made it here. Please welcome Craig and Yulia from Jamf to talk about zero touch, zero hassle. Over to you guys.
Cool.
Thank you.
Yeah, thank you very much. Yeah, how's it going, everyone? Yeah, thank you for arriving so early after the JNUC party last night. I'm surprised to see so many people have actually made it here. So, yeah, you guys are the true troopers in this one. So, yeah, look forward to sharing this stuff with you. So, yeah, forward-looking statement. It's day 3. You've probably seen this before. You know what the drill is. So we'll get past that quite quickly. And yeah, today we're talking on zero touch, zero hassle, rethinking secure access for Apple fleets. And that's centered around our network relay. So yeah, great to meet you. I'm Craig, and I'm joined by my colleague Iulia. And today, together with some customers, we're going to show you how Apple's latest technologies and Jamf implementation of them are reshaping what secure zero-touch access looks like for Apple fleets. And again, this is in the context of our network relay. So yeah, what we're going to talk about today is what's changing in access and identity, managed device attestation, zero-touch, zero-trust network access, and then, yeah, we have some customers here along for some use cases and to talk about that a little bit more in the panel. And yeah, so yeah, to kind of start off, I have a little demo here of where we're going and what we're going to try and achieve by the end of the call today. So let's hope that starts. Cool, here we go. So this is the Jamf Radar console. It's on my Mac enrolled in Jamf Pro, and it's just at home, so it's not on a corporate network. What I'm trying to do here is I'm trying to log into a corporate resource, Office 365, that's behind a conditional access policy. As of right now, there's no network relay, there's no Jamf Trust ZTNA on the device. Conditional access policies are stopping me from being able to log in. On top of that then, I have an on-premise resource that I'm trying to access that's in my office. That needs to be accessed via a site-to-site VPN. Again, not enrolled in anything, can't access anymore. And yeah, if we take a look as well just at the IP address that comes in here, yeah, that's my office IP at home, or it's my home IP there. So there's no network routing going on this device right now. As things stand, I'm currently completely locked out of any corporate resources. By the end of this call, what I'm going to do is by using network relay, I'll be able to effectively, without any end user interaction on the device, be able to access these resources. So yeah, what I'm going to do now is I'm going to hand it over to Iulia to say basically how the service works and give some background behind it. So over to you, Iulia.
Thank you. Hi, everyone. Good morning. OK, to kick things off, setting up the context and hopefully getting you to a place of understanding, let's first put into picture how the access security landscape used to look like and what we're looking at today. You have your users that need access to your organizational resources, right? Those could be websites, application servers, databases. And they need to connect to those resources from wherever they may be in the world. And then you also have attackers that want to have access to the same resources. The classic model for securing those resources has used to be traditionally the perimeter security, where you draw a boundary around your internal network, and then you stand up a firewall or a VPN in front of those resources that is going to permit legitimate traffic and reject threats. The problem is that this is not what the current landscape looks like any longer, right? You have cloud providers that for the past 10, 15 years now, they've been putting resources in the cloud, private cloud, public cloud. And then you're also having to deal with the insider threat, right? Employees that have gone rogue. And you have attackers that are spoofing legitimate clients' identity, and they're going to gain unauthorized access to those distributed resources. So all these changes to the enterprise landscape and the mounting threats that have been happening in the enterprise in the recent years have given rise to a more modern access security model, the Zero Trust Access Framework. This is built on a few key principles. First of all, you want the access evaluation to be tied to more granularly to individual resources instead of traditional VPNs where you had wide open networks. Then you also want to limit that access to on a need-to-know basis. So only the users that need that access to do their job should be granted access. And then there's this notion of continuous evaluation of trust, right? Not well beyond the login time. And last but not least, it's a very important principle of Zero Trust, where you're wanting to use rich contextual information to make access decisions. So you're looking at things like device identity, user identity, device management status, device security posture, device location, times of access, whatever. There could be any number of contextual data points that you can draw on to make those decisions. Essentially, in a nutshell, right, this is what Zero Trust is all about, right? You want to build that trust before you're granting access, and you want to be able to continue to reassess the trust posture way beyond the initial decision. Okay, and in a Zero Trust architecture, identity is foundational, is at its core, and everything, all those principles can only be effectively implemented if you have a solid grasp of identity. And when we say identity, right, we can think of user identity, and that's well understood, and it has to play a part. But yeah, in the light of security breaches that have been enabled by user credential theft and impersonation attacks, it became apparent that user identity alone doesn't cut it, right? You need something else to complement that. So device identity, we think it's equally important, if not more. So what we're looking to get here is find a unique, verifiable representation of a device that we can use to establish trust in that device and use to inform access decisions. And when we think of device identity, right, we can think of serial numbers, MAC addresses, UDIDs, but none of those are actually reliable device. Those are device identifiers, they're not device identity, right? They're spoofable, especially before Apple Silicon. We know admins such as yourselves, you were able to stamp over known serial numbers to VMs to test workflows and whatnot. So those are not gonna uniquely identify a device in a sea of devices. So here we have managed device attestation. This is an Apple platform security feature that provides a hardware-based cryptographic evidence or an attestation of a device identity and several core properties. This attestation comes in the form of an X509 certificate that is issued by the Apple attestation servers. And then managed device attestation offers two ways to use those attestation certificates. The first one is the device information attestation. This one is accomplished by the MDM server that's issuing this query MDM command with specifying a new key related to attestation. So this is the command. And then when that happens, then the device will generate, the secure enclave will generate this hardware-bound private public key pair. It's going to forward the public key to the Apple attestation servers that have access to manufacturing records and OS catalog. And the Apple will return, assuming that the device is legitimate and it hasn't been tampered with, is going to return this signed attestation, this certificate, that includes a number of attested properties. And then the MDM server can evaluate this attestation. So what this does is essentially telling the MDM server that a device exists with these properties, mutable, immutable properties. It doesn't prove to the MDM that the device that it's currently communicated to the MDM is the same device with these properties. Right? For that, you need ACME payload attestation. So that's the second attestation that managed device attestation supports. So what's that workflow looking like? I'm going to go over it. It's oversimplified. At the end of the slides, as part of our handouts, there is a resource for you to read way more about this workflow. But yeah, in a nutshell, Apple added support for automatic certificate management environment protocol, that's ACME in short, by adding this ACME profile payload, which makes the benefits of attestation available throughout the organization infrastructure. So the way it works is that the MDM is pushing this ACME payload, and when that happened, then the device, like in the previous use case, right, the device will generate this pair of hardware-bound keys, and is going to reach out to the ACME server, is going to establish initial communication. The ACME server is going to challenge the device to essentially go attest itself with Apple, which is exactly what happens. This will result in that attestation certificate being returned to the device. This certificate, again, it proves that the device exists with those properties. It's not usable, and as part of this ACME workflow, the next and ultimate, the final step here is that the device will request another certificate from the ACME server, including the attestation chain. And with that, the ACME server can return an ACME client certificate that can be used for TLS. So the value of this ACME client certificate is that it will allow other servers in the organization to trust that the device is who it claims to be. The device uses the same private key to get an attestation from Apple, to get that ACME client certificate, and then to using TLS to communicate with any other server in your organization. And just like SCEP payloads, other payloads in the profile can reference the ACME payload in order to use that ACME client certificate for TLS. So there's multiple uses here. You can use it for MDM, of course, for Wi-Fi, access to GitHub, VPN, Kerberos, Safari. It's plenty of ways to use an ACME client certificate. We are using it as part of our ZTNA infrastructure in correlation with another Apple tech that we're going to decipher in a minute. But to wrap up this section around ACME and device attestation, just to recap, so why does it matter? It proves a number of things. It proves that the device is a genuine Apple hardware. It proves that it is who it says it is. It proves that it hasn't been tampered with. And very importantly, it allows to establish this chain of trust within an organization, between the different servers of an organization. And yeah, as the MDM client identity, very important. We're going to move on into the next section, where we're going to learn more about how MDA, I'm going to say that in short, right? Managed Device Attestation, MDA, can support Apple fleets to come online and get securely connected to any networking service or application without the user having to open any agent and log in without any intervention from the user. And this sort of outcome of zero-touch access is possible because we took MDA and then we combined it with another Apple feature, Network Relay, and we integrated them in our Jamf ZTNA tech stack. And before I explain how all this hangs together, let's do a bit of a detour to talk about Network Relay. right? So we covered MDA, now Network Relay. This is another Apple platform security feature. It was introduced starting with the macOS 14 and iOS 17 as a special type of proxy that can tunnel TCP and UDP traffic. It is built right into the operating system, and it uses MASQUE, which is a tunneling framework built on top of HTTP3 and QUIC being the same transport protocol used for iCloud Private Relay. How many of you know what iCloud Private Relay is? Probably, yeah, all of you. So, but instead of masking personal browsing, which is the intention behind iCloud Private Relay, Network Relay is designed to securely route enterprise traffic. Okay, so this is where we're gonna build up a bit of a workflow, try to demystify a lot of it. But there's the demo that we'll have at the end that will also help to kind of complete this picture. Okay, so as I mentioned before, right, we took MDA and Network Relay, and then they're both now integral parts to our ZTNA, and they support Apple devices to connect into our cloud. We'll start with, right, we have your users, that your devices, sorry, that you manage in your MDM, and then you have your organizational resources, whether they're private application, on-premise, behind a firewall, or whether they're SaaS applications or IDP. And you need them to, right, be able to securely connect to those. And the way that's gonna be possible, that's accomplished and brokered through our global cloud infrastructure, ZTNA infrastructure, where at the core of our solution, we're looking at this ZTNA engine that you're instructing on how to behave and how to handle traffic through these access policies that you're defining. These are rules that you're setting up against your enterprise applications. There's one access policy per application. You're capturing the namespace, all the domains associated with that application, all the IPs, and then you're also defining what devices are authorized to connect to those applications and what security conditions those devices need to meet. Right, so that was already there. That's part of our ZTNA solution from a while ago. And also as part of those access policies, you're going to define the routing by which traffic that is allowed is routed from our cloud over to these targeted applications. So that's part of the configuration. Another configuration to make this connection from the end devices to these applications is going to require the administrator to create this configuration payload. That includes ACME payload and Network Relay payload. Right, so we understand the ACME payload, and the Network Relay payload, very importantly, is going to capture all those domains and IPs that you define in the access policies automatically. The moment you set up this activation profile, that Network Relay payload will come up with those IPs and domains already defined, as well as with the address of our Network Relay infrastructure, which we're standing up a Network Relay server in all of our edge data centers, just like we have WarGuard servers. We now have Network Relay servers. And very importantly, that Network Relay payload is referencing the ACME payload, right? So when you're dropping that, so yeah, let's see what happens. So you're setting that up in the Jamf Security Cloud or Radar, some of you know that, and then you're pushing that payload through the MDM. There's like a one-click button, you're gonna see that in the demo. And as soon as this profile with the ACME and Network Relay drops on the device, the first thing that will happen in the device is, we've seen it, right? It's gonna be that ACME exchange that will result in this ACME client certificate to be issued back to the device. When that happens, the profile is installed, the ACME client certificate, right, is stored in the keychain. And then now this device has this set of instructions telling it every time you need to connect to any of these IPs or domains, tunnel that traffic through the Network Relay infrastructure and communicate, use TLS communication authentication to secure that connectivity. Right, so that's what happens. Let's say that it needs to connect to a SaaS application, a tunnel is going to it's not going to come up. Again, it's just like these are micro tunnels. It's going to establish a connect stream. Not going to get into that. It's very technical here. So, but to simplify it, right, there's a tunnel over into our infrastructure, mutual TLS. And from that point, we know that this device is a company-managed device, and it's an Apple-attested device that hasn't been tampered with, right? That is a shift in sort of in the paradigm of VPN. You have the highest assurance that the device that is trying to connect to your infrastructure is a legitimate device. Now, that is not the end of the decision process. Right now, we're only going to start to look at the access policies and see, is this device even authorized for access? So regardless, you're a legitimate company-managed device, but you might, remember least privilege, you might not be authorized for access. So this secondary kind of processing of access happens once the traffic reaches our cloud, and we check all that traffic request against the access policies, and we might, again, reject it or we might allow it. Yeah, so in this case, we're showing that we're going to connect end-to-end. Yeah, so that's how kind of it all comes together. Yeah, hopefully the demo is going to help clarify further this, but we'll also have questions at the end. So yeah, let's go over what are the key features, key benefits of this solution. I'm gonna first call out the fact that with the Network Relay service, you have the means to bring your devices online with networking access already available, right? You have very specific, application-specific access that can happen remotely through MDM without users having to intervene at all in a zero-touch way. And then the access is going to be gated by this high assurance of device identity, which is hardware tested, right? So this is, I wanna stress that this is really important. What you're getting right now is a confirmation that the only devices that can connect into your critical applications are known company-managed devices. Think of other types of VPN, which are configuration-based. Anybody that gets a hold of that configuration and drops it on their own personal devices, if they phish someone's credential, they can connect into your infrastructure, right? So this provides this foundational identity, device identity assurance, which we think it's a stepping stone to fully realizing a zero trust architecture. And it's built on very modern networking protocols like QUIC, so it's making it very performant and very resilient between networks. Yeah, and last but not least, because of how it's designed by Apple, it's built to be able to be compatible with other VPN-based extensions. So it can sit right alongside your existing VPN provider, which means that you can kind of find ways, or if there's any use cases that this can unlock, it doesn't mean that you have to disrupt your existing ZTNA infrastructure. Yeah, and because of those key features and based on our conversations with our early adopter customers, I wanted to highlight the use cases that we see this being most conducive for success. Of course, any use case that involves a device where the user identity is not the primary driver there, right? So you have shared devices, or you have multiple users that perform the same job in shifts, and they just need to share that device. If you can secure that networking layer with Network Relay and leave it up for the IDP or the application layer to distinguish between the users, you're winning there, right? So shared devices, retail, hospitality, or we're going to talk about this use case a bit more later. Then you also have another one. Oh, I'm so sorry, I got confused here. Shared devices, okay. And the next one, headless devices. So devices where there is no user to open any agent and type in any credentials. So think POS devices, right? So that is also a prime example for using Network Relay. And then another one has to do with users that are on the go, that need to have ubiquitous network access from wherever they may be connecting from in the world. So we're calling this, the remote worker use case. And then there's another use case which is not going to be featured here, but it's very real, and we've seen it being implemented, or at least POC'd, with one of our customers that have to do with streamlining the Mac onboarding. Right? So if there's any, during Mac onboarding, right, that device needs to connect to a number of resources. If there's any sort of networking challenge that you have to get that device online, you can think of Network Relay as the means to unlock that network connectivity problem that you have. So right as we discussed, it can work very granularly just on certain IPs, certain domains, and that can be the medium by which you get past any onboarding, networking-related challenges. And I think with that, we're going to move into the demo.
Awesome.
Thank you, Craig.
Cheers. Thank you, Iulia. So yeah, now that we know how it works, let's see it in action in practice. So if you remember the video earlier on, we had a pretty fresh MacBook with effectively no enterprise network connectivity attached to it. I wasn't able to log into my Office 365. I wasn't able to access internal resources. And when we tested my IP address, it was showing, it was my home local IP. So learning, or going from what we learned with Iulia there and managed device attestation and network relay, we're going to kind of go through now how we'd actually put that into effect using the Jamf Security Cloud portal, or Radar. So this is Radar, as you see it now. There's a sync between this portal and my Jamf Pro instance. So once you get that sync set up, everything can be managed through this, but just know that kind of Jamf Pro is existing within the background there to push payloads out to devices. So in order to get this set up, the first thing we need is an access policy. And Iulia mentioned these a little bit earlier. An access policy is effectively a bundle of host names, some security posturing, and a route that goes from the devices through the Jamf Security Cloud and then out through whatever point of egress you want. If you have a look in there, you can see I have that one set up for my site.internal. And you create one of these for each of your things. Past that, you want to create an activation profile. An activation profile effectively creates the payload that you then push out via Jamf Pro. In here, you've seen I chose Managed Device Attestation to use Network Relay. I gave it a name, hey, Network Relay, and then I click Next. And then Save and Create. There we go. So once this is done, effectively we'll see what platforms we can push this out to. So iOS and iPadOS, or macOS. We're using macOS today. And then this is the payload that will be pushed to the device. It's a configuration profile. If we kind of scroll through it, we'll see where the managed device attestation check is. And what we'll also see in here is some match domains as I scroll through it. Any matches on these match domains will send traffic through the network relay and then out through whatever routing we want. So for my internal website, that's going over a site-to-site VPN. For my Office 365 services, that's going through some shared IPs. Once I have that, I can just choose what group I want to deploy it to within Jamf Pro and click the deploy button. That's going to send that payload as a configuration profile into Jamf Pro and then out to the device. And hey, if you have a look at that there straight away, we can see Network Relay is on the device. And if we check again, hey, there's the match domains. So now, effectively, what the OS is doing is looking for any traffic that goes through these. Should it match, it sends it into the relay, where we'll then route it accordingly. There you go. It's already on the device. I refresh my page. You can see, hey, look at that. My IP address changed there. If we have a look just within the payload here on the device, and we can see there's the configuration profile that came out. If we give that a click, we can see where the ACME certificate server is, when it's been issued. That basically means that, on the first connection to that site, my device passed the posture check with the managed device attestation. Passed the check, the route is open. hey, look, that's my other site there. It loaded in the background automatically by Safari. Last up is Office 365. I go through the login flow once more. And this time, because traffic is now going through Jamf, egressing from a Jamf IP, when it hits the conditional access check on the Microsoft side, hey, look, it's going to pass and bring me into my service there. So all of that managed to be turned on without any end-user interaction on the device. That was all pushed out via basically a one-click profile within the Jamf Security Cloud portal. And yeah, as soon as the payload hit the device, the first connection came in, the attestation check done it, network relay channel was set up, and hey, basically instant access to those services overall. So yeah, it's pretty cool. There was nothing in that video that was necessarily cut down. That was all live. The only thing I kind of did is I pre-linked the Jamf Security Cloud portal and Jamf Pro, and I pre-made the access policies, but everything past that, yeah, can be done really quick. So yeah, that's kind of it. What we're going to do now is we're just going to talk to some of our customers here that have started looking at and using our network relay to see where they can bring value to their businesses using it. I'm not sure if we have everyone here. I know we have Esteban.
Esteban, and I've seen Henk, I think, walking in. Yeah, so we have.
Oh, yeah, who wants to go first?
UMC Utrecht and Veg. Yeah.
Okay, we have Esteban there first.
Yeah, so if you guys join us,
yeah.
mind joining us?
Come on up.
Come on up, Henk.
Yeah.
You know, you've done a session yesterday, so no need to be shy here.
Here you go, Esteban.
So maybe we'll let you introduce yourselves real quickly, and yeah, tell us where you're from, because there are 3 logos here. So.
Hi, everyone. Good morning. I'm Esteban. I work at Veg. I'm the network security architect. I've been at Veg for like 3 years, and I've been privileged enough to have a chance to POC the network relay.
Thank you, Esteban.
Hey, my name is Henk Gottfried, and I'm one of the Mac admins at the UMC Utrecht. And yeah, I also had the time to POC on the network relay stuff from the Jamf side.
Thank you both. Both Esteban and Henk and UMC Utrecht have Veg. They've been using our ZTNA solution for a while now, right? So they were, for us, like immediate. We thought of them immediately when we were very early days with network relay. I think we reached out to both of you and we talked about the network relay with you both. And I wanted to ask you what was it that motivated? Maybe we start with Esteban. What was it that motivated you to just give it a try and test it out?
One of the core reasons that we wanted to try this out was that our leadership was asking us for a much easier user experience to use network VPN. Okay. Right. So the fact is, the users have to turn stuff on. We have to train them every time they do the VPN. Sometimes we'll even get tickets. Oh, my VPN is not working, and it turns out that they didn't turn it on. Okay. So network relay was perfect because it's kind of set and forget it. And it works wonderfully with iPads, which in turns is we're a 24/7 emergency service. So sometimes it takes a while for our computers to boot up, and it's much quicker to just diagnose it real quick in the iPads. Yeah. And has worked perfectly for my personal need to support Veg.
So right now you have it. So the solution is a release candidate availability for mobile devices, right? So I think you trusted it to then put it on your iPads. It is still in beta for Mac devices, and that's where we're continuing to work with you to.
On the Mac side, at least me personally, I cannot speak for my support team because the support team needs a little more features. Yeah. But I have not gone back. I've been using network relay since it got deployed to my computer, and I'd be able to support Veg in this current form that it is.
Thank you, Esteban. Yeah, and.
Yeah. And I guess, over to Hank. So Hank, you've been using our ZTNA product probably for as long as I can remember here at Jamf. And
since I was at Jamf.
Yeah, me too, a long time. So how are you finding that overall, just the ZTNA model in general with Jamf?
Yeah, so we started with Wandera, and it was still the Wandera age. And we needed a VPN solution for our macOS devices. At that time, we used Cisco AnyConnect. And Cisco AnyConnect wasn't really that secure for us, so that's why we decided to move over to a ZTNA solution. It's really easy to set up. It's really easy to use for the end user. It's just one click just to register your Mac, and the user is productive at seconds.
Awesome. And yeah, as someone who's one of our bigger users of the service, now that we're kind of taking it to another level with Network Relay, what ways do you think that could even streamline and improve your workflows a little bit more?
Yeah, at this moment I'm trying to, I'm building a POC on shared iPads in the hospital, and I'm seeing more benefits that users don't have to register their credentials in order to get the connection to the network. So it's really easy to do. You just did a demo, and it's just that easy.
Yeah.
Is it for what staff are these shared iPads?
For the medical staff.
For the medical staff, okay. So nurses and
nurses, mostly nurses, because they can then take an iPad from a wall and be productive when they need it.
Yeah.
Awesome. Well, yeah, cool. Thank you, guys. Yeah, we can't wait to kind of work with you on this and kind of get you guys into production and, yeah, solve some problems for you. So, yeah, thank you very much to our lovely guests.
Thank you both.
Yeah.
We have a session with Esteban and Carlos at Veg coming up at 10 a.m. in 1B if you wanted to learn more about how their journey of ZTNA. But yeah, if you don't mind staying on stage, maybe someone in the audience has questions for, ask us any question, any of us. We're here, we still have a few more minutes left. But yeah, thank you. Sorry, sorry, thank you.
Give them
I cut off the applauses for our guests, sorry. Okay.
And yeah, I guess, if you guys want to try this out yourself, there's a QR code on the screen. It's also included within the workbook there as well. So, or handout, sorry, handout, It's included within there. So, and additionally then we have some resources. Oh, I seen someone was trying to scan the screen. I'll leave that one up, so if you want to try this. And other than that, I think that about covers us for today. So we're open for questions either for us or for the guys here who are using the service. Just raise your hand and we'll get a mic to you. Yeah.
Good morning. Thank you very much for all that. Do either of you folks or, from Jamf Security, can you speak to any, did either of you have another ZTNA product in place already from one of the other big vendors that you took a look at this and were like, no, this is much better?
So.
Yeah, so you were a little bit hard to hear there?
Yeah, sorry. About the question is, did you have a ZTNA product in place already from another vendor?
Okay.
And decide that this fulfilled your needs better?
Yeah, at this moment we use Cisco Secure Client, and we are planning to dismantle the Cisco Secure Client, and we primarily going to use ZTNA from Jamf. Oh yeah, we have two ZTNA products enabled in our environment, and we're going to switch over to one, and that's going to be Jamf Trust.
And it's because, right, you're using the other ZTNA right now on Windows devices, and we didn't make it overly clear here, but our WarGuard type of tunneling has support for not just Apple, but also Windows and Android, right? Network Relay is Apple specific, of course, but then I think that's what you planned, right? You're planning to roll it out to the Windows fleet as well, yeah.
Yeah, so we are doing a POC now for the Windows devices. We got like 150 devices connected and doing some POC stuff. So we are looking forward in also ditching the other ZTNA solution and just concentrate on one ZTNA solution.
I had a follow-up. Is that common to do in terms of we're going to bring in one solution to work specifically with the Apple side and the Windows side? For Jamf as a company, we have actually a lot of solutions that go across platform.
Yeah. I mean, this was their experience, right, where they turned to Jamf for their Apple devices, but then as we continued to work together and they became aware that we have support for this and this, I mean, everybody wants to consolidate things, right? So that's been UMC's journey. It doesn't have to be everyone's. Cool. And Esteban?
I also like to add that our current setup is outside of ZTNA, we also have VPNs for security reasons, like we push our traffic through. Actually, we have 2 providers, and Network Relay works with it. Like I have been, I had to do some configuration on the back end, but it works without any issues.
Awesome. Cool. Yeah, I hope that answered the question. Anyone else have anything?
I have another one.
Yeah, let's go.
Go for it.
Most of the folks here are on the admin side, the management side. They'll be clued into the user experience, and many times they have to go to their network teams or go to their security teams to get help in implementing something like this, which is a very clear user experience use case, but it's also security. So both of you guys, I think, are on the security side, but was this your idea to bring in, or was it brought to you by folks, maybe it's the same people, who are focused on what would be considered the management side?
Well, I work closely with Carlos on our side. So when our leadership, like I had a lunch with our leadership, and they talked about this, and then I went to Carlos, and then Carlos somehow found out about Network Relay, and that's how we joined together to push it out to our organization.
Yeah, for us, it started with COVID. We needed a solution that will work at home. So it was a no-brainer for us to start using a ZTNA solution that's going to be secured for the end user at the end.
Yeah, that's interesting in terms of there's a situation that has to be responded to just to make sure the end user is supported, but it also has to bleeds into the security side. So getting those teams to work together is something that I know I've seen can be a challenge depending on the organization. But if you're both focused on the end user experience, it seems to work out.
Yeah, exactly. Cool. Any more for any more? No, well, if you have any further questions, you can kind of catch us around the show. Like Iulia and Esteban, you have your talk, in a couple of minutes. And then also we have a brain date on at 11?
11, yeah.
11 o'clock. So if you want to catch up with us there as well, you can go ahead and do that. Yeah. Where are we gone? There we go. There's some more additional resources. They're all in the handout, so don't worry about it. You'll get them later if you want some more reading. And then, yeah, last but not least, thank you very much. Thank you, Iulia. Thank you, Esteban. Thank you, Henk.
Thank you, Henk.